Hello all. A few days ago I received my oscilloscope so I can finally finish with the diagnosis and possible repair of the Amstrad CPC unit of the last video. I have already been testing on the oscilloscope some points and I have seen that the processor here, so the green cable I have put is going to the clock signal, that's the pin number 6, and the other one is the pin number 14. Yeah, pin number 14, that's data 0, and I'm receiving nothing here. So it should receive a 4 megahertz signal on the green cable right now, and it's detecting absolutely nothing. So I have it attached to a multimeter power supply, and I have traced back the clock signal and found that it has something to do with this hex inverter. This hex inverter is according to the schematics connected to the gate array. That's the gate array. And here in the schematics, so not very clear, we can see IC125. So this is IC125. I can see that on pin 6 it gets a signal through a resistor and comes from the gate array and is the negative phi, and that goes to the phi signal that on the other part of the schematics, if we follow it, comes here to pin number, yeah, it's not very readable, pin number 6. So this is the one here. So the signal gets out from the gate array, comes to the hex inverter. So what I have right now, I have put it on the input of the hex inverter and the output of the hex inverter, and we're going to see if there is any signal at all coming from the gate array. I have already tried the hex inverter. These two pins, at least these two pins of the hex inverter, are working properly, and have also tried the clock. The clock is getting a 16 megahertz signal. That's what it should be getting, and we're now going to see if it gets any signal from the hex inverter going to the phi bus, and if it doesn't go, it doesn't get anything, then I will do some other tries on the gate array and checking the some inputs or outputs, so negative sync, maybe the other clocks here, and see if I get any signal. If I don't get any signal, then I will consider that the gate array is basically dead, and that would be a problem because a dead gate array is practically the cause of a new working machine. So now let's connect the power. I have here the multimeter saying we have no power, so now I connect it, 5 volts. So this is now the circuit is connected. This bypasses the power plug on the keyboard, the power switch. And now let's try some capture here. So this was the test from the hex inverter also of the circuit. It was working perfectly. So now let's see what signals do we get. So it's getting something here. I'm going to do it auto setup, so let's see if we can get the signal. Takes a little to do the auto setup. Okay, this doesn't look proper. It looks mostly like noise. I will take a capture so you can see it better. But yeah, this doesn't look proper at all. So if I get this, this is not the clock signal that I should be getting at all. So let's try something else. So I'm gonna take out the probes from the hex inverter, out of here and out of here. And now, so this is the gate array pin out. Let's take out the power. Let's check. Yeah, it's on 0. Now, this is okay. So pin 24 is the input clock, 60 megahertz. So let's put the probe there on pin 24 here on the board. So pin 24. Okay. I need to take out the ground from here. Okay, pin 20 and 24. pin 24 here. Okay. Okay, so the prof is properly connected to pin 24, and now let's connect the prof to ground here. Prof to ground. Okay, and now, so this is the yellow prof. Let's give power, 5 volt. Now disable the pink prof, off, and auto. Yeah, this is a 60 megahertz signal. So let's save it. So the clock 16 signal on point 24 of the gate array is getting a 60 megahertz signal properly from the crystal. And now let's check another pin from. So pin 4 is C clock. I think that signal here. So let's take power out. 0. Okay. So signal here. So here is the C clock 4 goes to goes to a cache. No, that's not very useful. Okay, yeah, C clock here. Yeah, goes to pin 21 of the VDU. So this chip here goes to pin 21 here, and that's pin 4 here. So let's put it here, pin 4. 1, 2, 3, 4, pin 4. So this should be getting the clock for the CRTC chip. This is the CRTC chip here. Now let's give power, 5 volt, and there's nothing on the oscilloscope. Nothing at all. It's quite difficult to record the oscilloscope. Save a screenshot. Okay, save. Now let's try auto stop. Maybe the signal is another frequency out of what? No, this is just noise. This is millivolts of peak to peak. The frequency is on kilohertz. That chip works on more than kilohertz. This doesn't look good at all. Okay, so let's take it out. So another signal that we can check, if for example there's here signal 6 is VCC. So there's the video signals there. So pin 5 is the negative synchron video. That should be a composite sync. That should be detectable, but also horizontal sync and vertical sync. So this sync should be 50 hertz, the vertical sync, and 15 kilohertz the horizontal sync. And there should be about 1 volt, so not millivolts. So there's also the CPU here from the control and the phase signal. So let's try pin 19. That's the phase signal that should be getting out to pin 5 of the get. So pin 19. So pin 19 here. That's the phase signal. So if there is a signal here on phi that's not getting to the hex inverter, it means that the gate array is generating the signal properly, but it's not getting through the traces. So at least that would be something good. So let's give voltage. And I see nothing here. So I'm trying auto adjust. And yeah, that's not a signal. That's not proper. No. Let's power it down and try again. On the sync signal on number 5. So number 5 here, number 5 here. Okay, so number 5 power, and yeah, no. So well, I'm gonna save this so you can see. This is not a signal proper. So it's not even considered there's a product here. Earth 100 Hz. Yeah, that's not the synchronous signal for video at all. So a peak of 100 millivolts. So yeah, that's not proper. We have power, so it's not like that. And well, this means clearly this has the gate array is dead. There's nothing we can do about it. And if the gate array is dead, so there's nothing that can be fixed. Contrary to the Spectrum, where the gate array can be replaced by an FPGA implementation, right now there is no such a solution for the Amstrad computers. I hope there is in the future, because these chips, the gate arrays from Amstrad, they were custom as well, the Sinclair, but the thing is that the Sinclair were quite simple and they were not how they worked long before these ones. The one were the first decapped on 2016, so there's still the possibility that in the near future we have availability to replace this with FPGAs, and then it would be repairable. However, the seller is asking me if I have fixed it or not, and I will tell him, yeah, no, this cannot be fixed, and return it to him. Oh, so at least we tried everything, and now the oscilloscope will allow me to do more complex fixes and testing and so on. That this kind would not have been possible without the oscilloscope at all. So we know that there's no fixed signal. The gate array is getting the signal proper, is getting the voltage properly, it's getting the 60 MHz signal, and it has a divider inside, and should get the 4 MHz signal from inside, and no, it's not doing it. Also, it's not even getting hot, so I don't think it's doing anything at all. It's not a short circuit, it's more like completely broken. So see you in the next video, thanks for watching, bye!